Good evening. Like I'm gonna do the third talk about error handling. I hope you are all not super tired. I always get very tired after looking at code, and I have a lot of other code to show you. So maybe everybody should stand up and like move a little bit. Exactly. He's doing it. Yes, good. No, you don't actually have to do that. So let me introduce myself first. I'm Bert, and if you are into Twitter and stuff, I go by Piscasaurus. That, by the way, means golden fish. I don't know how I ever came up with that. It makes no sense. And if you did follow me, I've been working on Node and LibUV. LibUV is like what's inside Node, what does all the asynchronous awesome stuff for a long time. But nowadays, I work on that a little bit less, and I'm more focused on other things. And so one of these things is actually doing StrongLoop. And so this is one of my co-founders. It's Ben Nordhaus. Most people have never seen him, so I put a picture on there. This is somewhere, I think, early 2013 when we are just getting started. And so he's drinking beer as he always does. I'm drinking, this is called the Enterprise Kool-Aid. Because, look, when we started, that was actually Isaac's idea. He said, well, Node's getting really big, and so what we're going to do is make a lot of money with enterprise. And of course, we thought that was a great idea. And now it turns out that this is actually what enterprises look like. On Friday afternoon, 5:01, this is more or less what you will see inside. And of course, if you go there and you try to sell Node stuff, you'll get a reaction like that. And there's a reason for this. And so not actually a reason, but this guy thinks he has a reason. And so what reasons do people give us? Well, they say, well, flow control is really hard in Node. And my program crashes all the time. And it's really hard to debug it and to tell what's going on in my process. It has no threads. And by the way, NPM sucks. So of course we cannot solve all these problems at the same time. And so one of the projects I've been working on over the past couple of months, almost a year actually, is like solving a couple of these. So that is flow control and like making your program not crash all the time, and a little bit of this. And so to give you some context, let's first. I'm going to show you this sort of example. This is a very bad example, and I'm very happy that Adam set the stage for explaining what the contract is for asynchronous functions, because now you should be all be doing this exercise very easily. It should be super obvious to you. So we're implementing a function here. It's called curl because you'll probably all know what curl does. It downloads a website, and we are a little bit smarter, and we have a cache. So if we already know the result, we serve it from the cache. And so now my question to you is, and so please stick up your hand if you have an answer. There's a couple of things wrong with this. Can you point it out? I remember 3 things. So if you find more, then come on. You should see one,
Giving everybody a chance to.
Okay. Nobody. How disappointing. Oh, there's one.
So the callback rest.on data, there's no error. It just takes the S parameter.
Sorry. Yes, but that's actually right because that's how Node works. So a data event comes with no error. It just comes with like the content. So that's.
Is that the first if statement?
Yeah. Is there something wrong with that?
Because the original is the empty object.
Yeah. It already.
If your cache content is the empty string, then.
Well, I think it should work. I'm not sure. Okay. No. Okay. Let me just explain everything. So first of all, this is what Adam talked about. We're making a callback synchronously. That's not allowed. That doesn't follow the contract. And so, of course, what we want if something goes wrong and you call curl, but you give it like an invalid URL. Is it hard to read, by the way? Is that a problem for you guys? No. Okay. If you call this function, of course, you don't want it to just crash. Like that was one of the problems I mentioned. And so, anybody actually uses HTTP, the HTTP module in Node? I guess so. There's something weird with this. Do you know what? This returns an object. And so that object, an event emitter even, and that might emit an error. And so if it emits an error, then your node crashes. Now there's another one. And this one is really surprising to most people. What are we doing here? There's an end event, and we call the callback. And then when there's an error event on the response object, so you get two objects, right? The response gets passed to this callback, and the request object gets returned by http.get. And so, but there is no contract that says, and actually this can actually happen, that says that these are mutually exclusive. So sometimes what might happen is we end up calling this callback twice. And so in either of these situations, your program will break. Of course, like this is also not a little bit of a red flag for the Node HTTP API, of course. It's too surprising in my opinion. But what is this to demonstrate? It is definitely not obvious that like how to implement the contract that Adam described. And so some more stuff. Anybody recognizes this pattern? I think so. What we're doing, this is called a semaphore. So sometimes, of course, there's no actual meat here. It's just, an example. Sometimes you want to wait for, 2 events to happen before you continue with something else. And so now you have to count, right? I'm waiting for this stream to close and that process to exit. And so now I have to count, I'm waiting for 2 things, and then only when I've decreased the waiting count to 0, I can step to the next thing. And that's called a semaphore. And you have to do that sometimes in Node, which is not great. This one is, I'm going to skip this one. And so, well, actually, I'm not going to skip this one. This is sort of like a slimmed down version from something that we have to do in Node Core. If people make that error, or they call a callback synchronously, we have to sort of make up for that and undo what they're doing wrong. So you have to do this very weird thing where you detect whether they were calling the callback synchronously. And so it's my opinion that people should not have to deal with this stuff when you write Node stuff. I mean, it's really nice. It's JavaScript. You can get stuff done really, really fast. And so all this stuff should basically not be necessary. Now, it's of course, to solve all this stuff is really hard. But I got a solution. There's 2 problems here. We have the synchronization problem between multiple callbacks, or multiple like asynchronous things that happen at the same time, and we want to know whether like it worked or whether it's like we have to deal with failure basically. So I came up with this. I said, well, let's do. Oh, actually, this should be there. So let's do 2 things in parallel, and then put some sort of barrier here, and here we check. Did it go right or did it go wrong? So I proposed this to Brendan Ike, and he said, yes, sure, let's do that. That's super awesome. Let's add it to the language. A week later, he had to step down. So that was really unfortunate, and it's not happening now. And so we have to come up with another solution. And the solution looks like this. I've created a library called Zones. Actually, we released it today. And what you can do now is wrap everything that you want to have happen in parallel in a function block and pass it to some like thing called zone.create. And then for this entire block, there is a callback. Now the funny thing is that now you can do all these things that Adam would not let you do. You can, for example, throw an error in a callback, and we ensure that error goes here. And if you return a value here, and suppose we would not throw, would also go here, and there would be no error, but there would be a result. It also ensures that we adhere to all the parts of that contract that Adam described, in the sense that this will always be called exactly once. So if you think like, hey, the try-catch module that Adam wrote is actually pretty awesome. Well, it is actually pretty awesome. But it does like half the job here. Because in his case, you could go here, for example, 4 times if you threw there 4 times. And this should actually solve all the problems. So like this is a very simple example. And so I'd like to know whether you understand what it does. I see a question there.
Well, if you have multiple arrows that were thrown.
Yeah, so what will happen is only the first error will be routed here, and all the other errors are basically attached to that error object. So you can see the other ones. We do that because that's also, it is likely to see the same error multiple times, or one error can sometimes cascade through the system and cause other errors. But if you see only one, that's usually good enough. And for example, if you think about Node core libraries, there's like fs.readfile, for example, it does the same thing. If there's 2 errors, it will just give you the first one and assume that the second one is somehow related, and it doesn't matter. So, like, is there anyone who is like, what? I don't completely get it. There's no shame.
So you said that things in the function in the create are executed in parallel. Is that true?
Well, so of course, like if you like anywhere in Node that works like this, if you call http.get, it will do that like sort of in the background. And right after you call http.get, you call set timeout, so that timeout is sort of happening in the background, right? So there's no difference from normal Node code. Actually, that's one of the really nice things I think about it. Like in here, you can do anything you could do in Node, but instead of crashing, if an error happens, all this stuff all the sort of side effects will be cleaned up. Well, all the side effects, actually the resources will get cleaned up, and then it's routed there. Sure.
Is there any case where set callback won't be called?
No.
Any case where it fails?
No. Even if you leave this empty, it will call, and in that case there will be no error and no result. So the result will be undefined and error will be null. I saw another question.
So the second question is,
Sorry.
Instead of set callback, the function error result looks like an errorback, and it could just be passed as a second argument to the create.
You can do that indeed. But so, I mean, I cannot fit all that on a slide. It becomes very difficult. I see another question.
Yeah, so let's say you're making like 5 different calls in the top part, and they all have 5 different results.
Mm-hmm.
How would you set the callback for those 5 different results? Would that be one result parameter, or?
So of course, like there can of course be, you can have multiple result values, because you could in theory pass multiple values to this function, and so that will be all routed there. You cannot call zone.return multiple times. If you do that, then the second time it will throw and say, well, hey, you're setting multiple results. I don't know what to do with it. Probably have a problem here. And it will take it basically as an error. And so it will clean up and go to the callback. Yes?
So what do you do with the error in the first HTTP get there? Function error result, zone return?
Yeah, so that's a bug in this example. Like basically the error gets ignored here. So you should throw it in this case. This is also not how HTTP.get works. It should be a request.get, but let's take it conceptual. I'll do that many more times, by the way. So if you can laugh at me a little bit. Okay, so let's go a little bit further. So let's show you some. It's not actually a promise, but sometimes you don't really care about the result, and so you can just say .catch, and it will only be called if there's an error. And vice versa, sometimes you only care about the result, but you want to bubble up the error, and I'll explain that later. You can leave the catch out. So this is just sugar. Never mind. Now what's nice is you can actually also nest zones. That seems rather obvious, but I'm pointing it out here. And so what will happen if you throw the error, if here's an error, then and the error goes there, then you throw it there, then of course this is like something in the outer zone, so then it will clean up all that stuff. It will cancel the timeout, I think. Yeah, I'm canceling timeouts nowadays. And then, of course, the error will be routed here where it, in this case, gets ignored. Probably you shouldn't do that. But just to point out that you can nest these things. Now, if you do something like this, it's really nice. And that seems, and I'll explain you why. Is there names here? No, there's no names here. You have to imagine Node as like basically a flow of things that happen at the asynchronously. So there's multiple things that could go on at the same time. Like here's a read. Like let's say there's a time dimension here, and so at the very first tick of Node, we call set timeout, and we create a server. And then, so you can think of, there's a set timeout sort of waiting in the background while other stuff is going on until at some point the callback is made. And then, there's actual JavaScript related to your set timeout running, the callback for the set timeout. The same goes on if you create a server. There's like, for example, there underneath there will be a function accept that's basically waiting for an incoming connection until at some point there's the callback, and then we're in JavaScript again. And suppose in that callback we say, well, let's read from that new connection that we accepted. Then it pens for a while, and then there's the callback. And so what you will see at any point in time, there's only like one JavaScript thingy going on. So here's a callback running there. There's never two JavaScripts running at the same time, but there's stuff happening in the background, or Node is waiting for it. I don't know if that makes any sense. Yeah, that makes any sense, of course. I hope you understand it. And so the thing is, if you throw in JavaScript, then what Node can tell you is, well, it happened in this callback right now. Node only has the concept of like the right now. What it doesn't tell you, but what it could tell you is, well, in the background we have a read going on, and there's a timeout waiting, and we just started a write before the error happened. Now, this is usually not very useful. If you see if you throw in Node.js, you see a stack and it's like this long, and it has like all these internals there, and you're like, what is this related to? And so, however, if we create a zone, that basically becomes sort of a block around a couple of, the zone contains asynchronous things. So if you start if we would say, well, the timeout, we did that outside the zone, but inside the zone we said, well, accept a new connection from a server, and then in the callback read, etc., and shutdown basically means send the end, then send the sort of end of file packet over the wire. Then here you have a group of asynchronous things happening over time. Now, if we nest a zone, suppose that we created another zone actually to read the data from the socket, but the writing was in the outer zone. Then you get another layer. And so now imagine that an error happens again here. We can sort of penetrate that way, and we can see, well, we were in the red, and the red was in the brown, and the brown was in the global thing. So basically you get another dimension to your stack. Not only can we tell you we were in this callback, we were in a group of asynchronous things, or it was in another group of asynchronous things. So, like for example, how would you do that? Create a zone, give it a name. You can name it. We call it outer task. We create a zone inside, and with inner task, and in there is a set timeout. And the nice thing now is that we actually can look at that dimension and see the asynchronous stack trace. So we could say, well, this was the callback. This was when we created the red group, and this is how we created the brown group. I hope that's sort of understandable.
So do the errors only go back to the nearest zone, or
the error? Sorry.
So let's say that if you go back there, let's say your red zone is only covering shutdown.
Mm-hmm.
So would the stack trace just show till shutdown and then all the way to the brown zone, or would it show every function call in between?
It's no. It's so. Suppose the error happens. You mean the error happened? The error is thrown there. You mean?
So let's say you only create a new zone around shutdown.
Mm-hmm. Yeah.
When you get a stack trace, would it show all the callbacks in between, like write and read and all the other ones?
No.
The brown and, okay.
No. So the stack trace, it goes that way. Suppose the red is stacked onto the brown, so it goes that way. So it says it was in a callback for read, and this whole entire red thing was created somewhere here. So in a callback for accept. So it's not a history just like a normal stack trace in synchronous code. It doesn't tell you all the functions you called before. It calls you the nesting of the functions. And so whoop. Oh yeah. So I can actually show you this. So we could actually run that example if it worked. So lib, I know, say show. So what I showed you with inner task and outer task, that's obviously not super that's not a super way of naming things. Instead, what you should probably do is name your functions after the abstraction level. So inside, you could say it could be a database query, and the brown zone, it could be handling an HTTP request. And now to the zone repository, I added an example where we do this. So we create a zone in which a server lives, and let's do the other one. Sorry, this is a little bit confusing. Sorry. Let's create a zone called client zone, and in there's a couple of we're gonna make HTTP post requests like many times to an HTTP server. Now inside that client zone, we're gonna create for every post request. We're gonna let's see. Oops, I'm at the wrong place. Sorry for the confusion, people. Yes, for every post request, we're gonna create another zone. And so you can see how this drills down from a global abstraction like the server to deeper, more specific layers. In this case, for every request there is a zone, and in there we could create another zone. We're not doing that. And actually we're gonna name the zone not request zone, but we're gonna change the name a little bit so it tells you more when it prints the stack trace. But what I'm going to tell you is that server, that's not super reliable. So sometimes it just hangs up. And what we now can do is actually tell what and at what layer of abstraction the error happened. Hopefully, of course. Terminate, and we're going to do it like that. No demo. Yes. So what we will see here is that it falls off, right? Shit. Okay, here it says error, but error, socket hang up. That's because the server did that. And so here's all kinds of stuff, internal stuff in Node. And then it will tell you, well, happened in a zone, and it was trying to post to this URL, hello/2. And and this is the stack trace for when we called that, when we created that zone, when we started that operation of posting. And oh, by the way, this is not super useful, but for the example, it's nice. This all happened in sort of another global zone, which was wrapped around all the requests. So now you can actually have context when you see an error. The other nice thing is that, and let's go back to that file. We are just printing the stack. We're not crashing the program, like what Adam pointed out in that domains page, do not ignore errors. You can safely do that here. And the reason that we can safely do that here is because the zone, before it reaches here, or before it would go to the successful return function, it will ensure that everything in here is sort of cleaned up. So all the sockets will be closed, all the timeouts will be cancelled. Well, the interval, if there's any, will at least be cancelled. If there's other stuff that might linger around, fill up your memory, make your computer run out of resources, all that, the zones will take care of cleaning all that stuff up. Okay, well, that's zones for now. Let's go to the future a little bit. The empty slide. It is my opinion that callbacks and the airbag contract that Adam described is not completely, is not super nice. It's not the future. Eventually, what we want to do is be able to, just say yield or whatever, or async or await an asynchronous function. And whenever you say yield, in this case, we say it at the end of the function, your code this function might be interrupted, other stuff might run until this is actually done. So Go is a well-known library that implements that already, and so if you want to, for example, download 3 websites in parallel, this is what it would look like. You save. We assume that this has been wrapped in some function that makes it actually possible to yield it. That's a little bit complicated. But we assume that's there. And so we get 3 funcs or 3 promises back from this entire call, and then we yield it, and here it sort of interrupts the code. Now this is, of course, sometimes this is really useful. I think this is nice, but not completely cool. Because you can never really tell, you have to, first of all, you have to explicitly yield everything, even if you don't care about the result. And you can never really tell what's going on in here. Like maybe, it produces an error, but the file is still open, whatever. And so zones still also will help you here. So this is probably what I'm describing. So you can put a try-catch block around that and then catch the errors. However, you won't know what's going on in there. So what I'm proposing is to make zone.create also return a sort of a promise or a thunk. And that means that you can now yield it. But the zone, of course, still contains everything, and it still implements that contract. So now you suddenly don't have to care about it anymore. You know that the zone will have your back, and if anything goes wrong in here, we'll just route you to the error handler. That may work for some stuff. I think for the future we'll have streams also work with yield. I think that's a little bit out of scope for this presentation, and it's late, so let's skip that. I would say we released it today, actually. It's in beta stage or in alpha stage. I'm interested in feedback very much. So at this URL, you can actually check it out. We wrote a blog, so just go to our website, and there's a blog that implements, that explains this stuff. And if you have any questions, you can tweet me or whatever. Or if you have questions, you can ask them now.
So when is it landing in Node Core?
It is not anytime soon landing in Node Core. Let's first wait for 0.12 and then, maybe after that. Or maybe not.
How expensive is this? Would you recommend wrapping every request?
So right now, it's a POC, basically. So it is kind of slow. I think it's an X4 slowdown right now. We think, because the things it actually does, it's very similar to domains, that it can be almost as fast as nothing, like normal code. So I don't know, domains maybe takes up 5% of performance or so it should be similar to that.
So what cleanup are you doing?
So what we do, the cleanup is a bit more complicated, but I can show it to you. So let's go to another zone demo. It's called in pull up, showcase, inspect. I have to run some stuff for this, sorry. So let's go another one, the zone, showcase, inspect.js. So let's see. So what you of course don't know yet what you're seeing. So let me explain. This is a snapshot what goes on inside this other process that I just started. So there's a tool in the zone repo and it shows you what's going on. And so what we see here is, there's a server zone. It has a TCP server inside, and that's maybe not so interesting. And here's another zone that I named connection zone, and there's we are reading something. There's a set interval call in another zone, and there's a TCP thing open. So here's how it works. If an error happens, we're gonna walk that way, and we're gonna ask the read, please stop, and we're gonna tell it it was for reasons of an error, and that makes a little bit of difference. In case of a read, in case of error, we just stop reading. We're gonna ask the set interval, and the set interval works the same. It stops producing callbacks when an error happens. This zone will then this is gone at some point, and when this is actually gone, the interval zone will be empty, so it will return. It will say, well, I'm empty. So it will call its callback, and then when the callback is called, we will go to the TCP handle. And the TCP handle normally does not close itself, but at that point, the connection zone is basically empty because the TCP connection does not produce events by itself. You can read from it, and then you can get events. You can write to it, and then it can produce events. But because this is idle at that point, it closes itself, and then the connection zone is cleaned up. And after that, of course, because there was an error in there, we call the callback with the error.
So how is this different from aren't you just essentially implementing domains?
Domains, no, that's very different. So what domains does, if it tries to clean up, is what has been added to domains, and then it will try to call destroy, close, and maybe another function. And if that all doesn't exist, it will be okay.
So how is that different than what you're doing?
There are cleanup handlers in here that are reliable. So they register all these things that can produce events or that are resources. They know how to clean up themselves. And because you can only compose, you can compose higher level construct, but eventually you'll have to use stuff that Node Core provides. And so because all the things that Node Core provides know how to clean up themselves, it has now become reliable.
So why doesn't domains just do that?
Good question. I didn't design domains, but yeah, so we could maybe change domains, and I would break everybody's.
So conceptually, though, it's similar to domains in the sense that is it on the uncaught exception handler that you're invoking the cleanup?
We're not doing it in an uncaught exception handler, but what we're doing is do you know something about the Node internals of Node? There's a binding layer in there, so there's like secret functions, and those are used to implement all the actual functions that you get when you do require tree, net, or fs, or and the secret functions we put a wrapper around that, and they do two things. If they are a resource or an asynchronous function, they register themselves, and if there's a callback in there, they restore the context. So that's basically the latter one is similar to domains, and then event emitters and streams are a little bit more complicated. So we actually changed the implementation a little bit at runtime. For example, to solve this problem that you described, where if an error handler throws, and the next error handler will not be involved, etc. To solve all these problems. So so there's more rules involved. You should probably read the README for the zones library, because it takes a lot of time to explain everything. But I can, for example, if you have an event listener, the event handler will be called within the zone that add the listener, and not in the event listeners, not in the zone that created the event handler. So that created the event emitter. Excuse me. So it's hard to explain. There's a lot of edge cases, so that's also why it took a long time to design it, because you have to very closely piece all these puzzle pieces together. Any more questions?
So to understand correctly, you exit from a zone by calling the return function. Is there anything that deals with semaphores? So you want the first return, or you want when all the returns are done?
Sorry, yeah. So the semaphore problem was you're waiting for multiple events. Now, what happens if you if in a zone you create two things that produce a callback, then the zone will not go to its own callback. So a zone has a callback, right, which runs in the parent zone. So let me pull up a slide, otherwise it becomes too muddy. Right. Okay. So here's a zone, and when this is completely done, then it will go there. So this now becomes a semaphore, because it will wait for both the fs.stat and the http.get to complete. So you no longer need a semaphore. That's basically the idea. Any more questions? Akil.
There's a lot of duplicated stack frames in your consolidated stack frames. Can it be compressed?
Yes. So the question is, can all the duplicate stack frames be compressed? Yes, we have a plan for that, but it's not there. So you can imagine indeed that you could say, well, so the inner task was created synchronously in the outer task, so we could basically strip all this piece out of that. Yeah, we should probably do that, but it's a little bit more complicated than that, because sometimes you might enter a zone from it, and from a zone enter the parent and then re-enter the child. So there are some edge cases there that we have to work out. The last one, I guess. Otherwise, everybody wants beer and stuff.
What's the relationship between this and Dart zones?
Well, the name is the same, and otherwise not so much. However, what we're doing is there's a guy called Brian Ford, and he works on the Angular project, and he also came up with a zone library. It's for the browser, and it is somewhat similar. So we're trying to merge concepts. Here's, for example, he does not provide a callback for zones, but it keeps context. It does async. It does async stack traces. So there must be some place in the middle that we can go, or maybe have two types of zones. One that is very smart like this one, and something that is a little bit more simple like his, and define one as a sort of subset of the other. So we're trying to do that. It would be really nice for this to be also usable in the browser, in my opinion. Okay, well, the very last one.
Is it really necessary to guarantee that you recover from errors?
Is it, well, I mean, like, is it necessary to guarantee recovery from errors? Well, I would say yes. Like, there's many people that come through Node.js and they're used to PHP, to Java. And what happens in Java if you have, like, you had your contact form implemented by the intern and he has, like, I don't know, a bug, a null pointer exception in there, then your contact form will, like, show this, like, red line, like error and server error, and then a stack trace, and then your server won't crash. And in PHP, because it handles every request in a new process, your process may crash, and then Apache will show you some 500 error, but the next request, your process a new process will be started, so it doesn't matter. However, in Node, as Adam described, it becomes sort of a denial of service risk to not recover from errors. And it's also just what people expect. So I think it's really nice if you could do that. We have to be a little bit more ambitious than just saying, well, we don't really know how to do this, so let's just crash always. Like, I think, I mean, so that's so far what we've done in Node, and it's still very useful. But we can be more ambitious. That's what I.
Have you seen my whole thread?
Your whole thread?
Oh, there's like an epic GitHub issue on Node where I basically had it out with Isaac on exactly this topic, saying this is not acceptable, we need a solution. And he couldn't even, I had difficulty even bringing the conversation to the point of mutual understanding to even talk about addressing the issue of, denial of service liabilities.
Yeah. I mean, so, yeah, it's, that's sad. I think also for a long time, I had the same thing, like, it wasn't imaginable how this could ever be solved. So, I have the same problem as a maintainer. You go into denial. You're like, I don't know, we don't know, but this also kind of works. And so, yeah, I think you experienced that. But yeah, like over time we can solve problems. I think try-catch was a really nice attempt. I think it's really useful. But like for example. If you throw twice in a block of code and it actually invokes your callback twice, that violates your contract.
So I solved that with Step Up.
Okay, yeah.
With my control library. And also, I would probably just use your internals in try catch. So I'd use this instead of domains because I never wanted to write that. It's like I just wanted to exist.
Cool. Well, I mean, so I have to admit, by the way, like it is demoable. It actually works. There is a lot of stuff that is not, if you create a UDP server or you use like fs.watch, whatever, it doesn't work yet. So what is now on GitHub is actually sort of alpha stage. So if anybody wants to help and has conceptual problems with what I'm proposing, then, open an issue. That would be the best thing, or grab me. Well, thank you very much.